Hello, this is Math 2115 coming to you from the College of DuPage during the fall of 2020, and this is the continuation of the lecture entitled Set Theory. When we left off, you were working on this problem, and you had about 10 of these that you were supposed to do, these numbers. I'll give you a little bit more time. You know what to do. Let's see how you did. Please make sure that you did get these answers, because making mistakes now is an opportunity to learn. They will be more costly if you make mistakes later. There's a problem dealing with subsets. You're to determine which of these statements are true and which are false. You know what to do. Let's see how you did. You should have gotten false, true, true, false, and true for these reasons. This next problem deals with what's the difference between this symbol and this symbol. They look kind of similar, but they are different and have very different meanings. So using these, which of the following are true statements? You know what to do. Let's see how you did. So A, D, and F are true. If I ask you this kind of question, I'll ask you why, if something, you call it false, why it's false. And let's see. So if we look at B, that's the set containing 2, which is not an element of this set. In this one, 2 is not a set, it's just a number, so it can't be a subset. And in E, this is an element of this set, but it's not a subset of that set. So E is false as well. A partition of a set X divides the set X into non-overlapping subsets. More formally, a collection script S of non-empty subsets of X is said to be a partition of the set X if every element in X belongs to exactly one member of S. Notice that if S is a partition of X, then script S is pairwise disjoint and adds up to, or the union, is X. At the beginning of this section, we pointed out that a set is an unordered collection of elements. That is, a set is determined by its elements and not by the particular order in which the elements are listed. Sometimes, however, we do want order to matter, and an ordered pair, written parentheses A, B, into parentheses, is distinct from ordered pair BA, unless, of course, A is equal to B. Put another way, the only way those two things can be equal is for the first element to be equal and for the second element to be equal. So if X and Y are sets, then we will define X cross Y to denote the set of all ordered pairs XY, where the first element comes from the first set and the second element comes from the second set. We call this the Cartesian product of X and Y. So here's a problem for you to do. You know what to do. Let's see how you did. So it's no, yes, and this is the answer to the third question. Both the first and second elements are the number 1. Here's a problem dealing with Cartesian products. So this is set A, B, and C. You want to calculate these things and answer the questions. You know what to do. Let's see how you did. Let's see how you did. Here are the answers you should have gotten for the first 3. A cross B has 6 elements. Here's the answer for E. F is up here. And G, this is the Cartesian plane, is what you get. So that's the set of ordered pairs XY, and it can be represented in that way. So that is R cross R. Ordered lists need not be restricted to 2 elements because you can have an in tuple, and that could be A1, A2, ... continuing through AN. And that takes into account that the only way ordered pairs in tuples can be equal is for every element to be equal. And the Cartesian product of these sets is defined to be an n tuple where each element x1, x2, dot, dot, all the way xn, small x sub I is in capital X sub I, and it's denoted in this way. So here's a problem for you to do. You know what to do. Let's see how you did. After the break, we'll see how you